Now we're moving on to a new section that is society's economizing problem. So I actually talked about this at the very beginning of the lecture. Society's economizing problem is that they have limited resources and unlimited wants. And I told you then we'd get to what the economic resources are, and here's your list. So the first thing I want you to notice is the economic resources are also called factors of production. So keep in mind, we'll sort of flip-flop terms between the two. Just know that they mean exactly the same thing. So these are all the things that society has that they can use to produce more goods and services. So these are all the things that go into producing more goods and services. The first one is land. And they actually mean a lot more than just land. So land can be any natural resources that society has, or sometimes we can import those natural resources. So we actually import a lot of oil, and then we can use that to produce goods and services. The next one is labor. This one's pretty easy. This is just all of the workers in the economy. So if you're hired on, you get a paycheck, you're considered labor. The next one is capital. And capital is anything that's man-made that goes into producing goods and services. Now, what you want to jot down here is equipment, buildings, tools, machines. Think of all of those things as capital. I also want you to make a note here. If you are going into business, you've taken a few business classes, capital actually means something a little different in economics than it does outside of economics. So capital in economics always means physical capital. It's a piece of equipment. Capital outside of this class a lot of times means some sort of financial investment. So, or money, right? So don't think about it that way. Money is not one of the economic resources. Another word you make sure you want to know is the word investment. This is another word that means something a little bit different in economics than outside of economics. So in other business classes, investment may mean that you are investing your money so that you'll get a return on your money. In economics, investment always means spending on capital. So if a business is investing, it means they're purchasing a new factory or they're purchasing new equipment. They're expanding their business, but they're doing that by purchasing more capital. And then the last resource is entrepreneurability. And this is a little bit different than our labor force. Our entrepreneurs are actually our business owners, so that makes them distinct from labor. They're going to be doing different sorts of activities. They actually employ the other factors, so they're going to take the land, labor, and capital and make the decisions about what to do with them. So they make business decisions, they innovate, they take risks. So think of entrepreneurability as the business owners. Now we're getting into the production possibility model, and we're actually going to spend a lot of time on this. This is the rest of the lecture is about production possibility model. The production possibility model is going to help us to understand society's economizing problem better. So it's actually just a graph that shows us that society has limited resources and they have to make choices based on those limited resources. So we're going to look at an economy that has the option of producing two different goods. So we have pared down here, we've gotten to a really simplified example. We're only going to be producing two goods, and we're going to put those two goods will end up on the axes of the graph. So these are some basics of the model. This one I talked about already, the two different goods. One of them tends to be a consumer good, that's something that the households consume directly. So it's used directly to satisfy our wants. In this example, it's pizza. And then the other good we're going to choose is a capital good. And this is the exact same definition from the last slide. So a capital would be a building or a machine or equipment, or tools, or something like that. In this example, it is industrial robots. So we have our two goods that the economy is going to choose to produce. Some things we'll see on the graph. This is actually a snapshot in time. So the economy has a set amount of resources. They have a certain amount of land, a certain amount of labor, a certain amount of capital, a certain amount of entrepreneurs. That's not going to change on the line, on the curve that we're going to draw. They also have a set amount of technology. Now, technology is another word that has a little bit different of a definition in economics. So whenever you see the word technology, I want you to think knowledge. A lot of times we even just call this technological knowledge. So it's what we know as a society total, the knowledge that we understand or the techniques that we know to produce goods and services. That's what we mean by technology. And since this model is a snapshot in time, then we have a set amount of technological knowledge in the model. The other thing we're going to see from the graph is full employment. When we're actually on the line, we are at full employment. And a lot of times the first thing you think of when you're thinking about full employment is the labor force. So you're thinking, okay, everyone has a job. That's full employment. And yes, that's true, but it doesn't only apply to labor. So all of our workers are working, but also all of our land is being used and all of our capital is being used. So we have full employment of all of our resources. Now, let's get to graphing. When you're graphing the production possibility curve, you're going to get a chart of information that looks something like this. It's going to tell you the two different goods that society is making. So our society is making pizza and robots. And it actually says pizzas in 100,000s and robots in thousands. Keep that in mind. We are on a huge scale here in the economy, but I'm not going to specify that from now on. I'm just going to talk about one pizza or one robot. Just makes it a little simpler. And then you're going to be giving all of the different production possibilities. So the idea here is that the economy can choose to produce at one of these 5 points. For instance, if they're at A, what they're doing is they're taking all of the resources in the economy, they're only making robots. So they're able to make 10 robots, and then they don't have any pizzas at all. Or, if we look at point E over here, then the economy is only producing pizzas. So everyone in the economy is making pizzas, and no one is making robots. So those are the two extremes. Probably instead of only having robots or only having pizzas, they're going to choose something in between. So maybe they'll choose to be at point C. At point C, they're splitting their resources. So half of the people in the economy are producing pizzas, and they've got 2 pizzas. And the other half of the people are producing robots, and they get 7 robots. So keep in mind that these are the different production possibilities. This is how much they're producing, but they only get to choose one of the points. So these are the possible choices, and then they're going to choose one of the points. Now, on the next slide, we're going to take each of these 5 points and put them on the graph. Okay, here's our graph. Notice we have one of the goods on the bottom, so pizzas are down here. The other good is on the other axis. And then these are the same points that are on the last slide. So at A, here, they're only making robots. So they've got 10 robots, and they have no pizzas at all because everyone in the economy is making robots. And then we have point E, And this is where everyone in the economy was making pizzas. So they had 4 pizzas and no robots at all. And then I also mentioned point C, where if they're at point C, then they may be able to have some of each. So I think they had 7 robots and 2 pizzas at point C. There's 3 different things that we can learn from this graph. The first is the difference between an attainable and an unattainable point. And this is actually the same as the budget line, and they have it on the graph for us. All of the points down here are attainable in the economy. So if we're here and they want to make 2 pizza and 6 robots, they have plenty of resources to do that. So that's considered attainable. Any point out here, like they put point W here, and it looks like 8 or 9 robots and 6 pizzas, this point is unattainable. Unattainable means the economy does not have enough resources to produce at that point. So think of attainable as possible. Yes, we have enough resources. Unattainable is impossible. No, we don't have enough resources. The next thing you want to know is the difference between an efficient and an inefficient point. So efficient means that the economy is using all of their resources to the best of their ability. And an efficient point will happen somewhere along the line. So I just drew out an efficient point, and all of the points that are on here, actually A through E, are also efficient points. Anywhere on the graph is considered an efficient point. The other thing you want to know about these efficient points is this is also called full employment. Full employment. And remember what we said about full employment earlier. It means all of the resources, land, labor, capital, entrepreneurs, they're all working, right? Now, an inefficient point, inefficient means that not all of our resources are working. So an inefficient point would be one that's underneath the line. So a point like here, that would be considered inefficient. And an inefficient point is also what unemployment looks like. Unemployment. So unemployment means that some of our resources are not being used. So we have some workers that aren't working, we have some capital, maybe there's a factory that's not being used. So remember, inefficient goes with unemployment, and efficient means that we have full employment and we're using all of our resources to the best of our ability. Now let's talk about opportunity costs. So one thing that's different between the budget line and the production possibility curve is that the opportunity costs in the production possibility curve will change over time. This is called the law of increasing opportunity cost. If we produce more and more of a good, its opportunity costs will increase. So the idea being the more pizza that we make, the more robots we're going to have to give up to produce that one more pizza that we're going to make. So I'm going to show you how to solve for opportunity costs from the chart and then also from the graph, because you're going to run into both of them. Okay, so let's talk about the opportunity cost of our first pizza. So if we were making no pizza and we wanted to produce one more pizza, the opportunity cost is the trade-off. What do we have to give up to get that one pizza? What you're going to do is you're going to look and see how it changed on the other good. So we had 10 robots, now we only have 9. So to get one pizza, we had to give up one robot. So the opportunity cost of the first pizza was one robot. Now let's look at our second pizza. So now we're getting one more pizza. We had one, we want our second unit of pizza, and see what's happening down here with robots. This time, we had to give up 2 robots to get that next piece of pizza. Now, the third pizza that we're making, we had 2, now we're getting 3. This time, to make 1 more, we're having to give up 3 robots to do that. So notice that it's increasing. That's where the law of increasing opportunity costs come from. The more pizza that we make, every time we make 1 more pizza, we have to give up more robots. So for the first one, we gave up 1 robot. Second one, we gave up 2 robots. The third one, we gave up 3 robots. So the opportunity cost actually rises as we make more of the good. Now let's look at the graph and see how we can solve for opportunity costs from the graph. So here's the graph. The math on this is actually exactly the same, but it's a little harder to see on the graph than it was on the chart. A lot of times they'll tell you what point that you're at already. So let's say society is at point B. At point B, they're producing 9 robots, and I think it was 1 pizza. It doesn't line up perfectly. And it will ask you the opportunity cost of producing 1 more pizza. So you want to figure out where you are and where you're going. So we have 1 pizza right now. If we want to produce 1 more pizza, that's going to move us from 1 over to 2, which is point C. So we're moving from B to C to get 1 more pizza. And then look at the other part of the graph at the robots and see how much you have. So starting, we had 9. After we moved to the new point, we only had 7. This difference right here is what it costs us. So we had to give up 2 robots to get 1 pizza. If you have some trouble with graphs, I would suggest just sketching out the points that you're at. So make sure you can see you're at 9 robots and 1 pizza, and then at point C, you're at 7 robots and 2 pizzas, and that will help you determine the opportunity cost a little easier. A little bit more about opportunity costs here. You do definitely want to know the law of increasing opportunity costs, but you also need to know that this is the reason why it's not a straight line, that it's actually a curve. So most of the time, you've probably noticed this, I tend to say production possibility curve as opposed to production possibility model, and that's because it is always a curve. So the book says it's a concave shape. A lot of times I'll use the term bowed out. It just means the same thing. So it's curved out a little bit from the origin. And this is how it actually would look in real life. The economic rationale behind that is just the fact that certain resources are better at producing one good or the other. So if we're talking about robots and pizzas, we have some pizza ovens that we've made. They're really great at making pizzas, but if we tried to use them to make robots, they wouldn't be very helpful. So that's why we see this law of increasing opportunity costs. So make sure you know the reason why the production possibility curve is a curve is because of the law of increasing opportunity costs. The next thing we're looking at here actually answers the question, which point on the production possibility curve do we want to be? So we know we want to be at an efficient point on the line. That's the best place to be, full employment. But we could be at A, B, C, D, or E on that graph that we were looking at. So to figure out the optimum point for society to be at, we actually have to weigh the marginal cost and marginal benefit of each of the goods. So this graph right here, don't worry about it too much right now. We're going to dig into this graph later on in the class. It's very similar to the supply and demand graph, which we will do in chapter 3. So the main takeaway that I want you to see for this chapter is our optimum point is going to be where the marginal costs are equal to the marginal benefit. So they've actually graphed the marginal costs and marginal benefits for us. You can see we're looking at pizza right now. So the marginal cost of producing pizza increased. That's the law of increasing opportunity costs. That's why marginal costs are rising the more pizza that we produce. The marginal benefit of pizza is falling. And we will talk about the law of diminishing marginal benefits in chapter 3. But we actually derive less benefit from pizza the more that we make it. And that's true of all goods. So when we're weighing the marginal costs and marginal benefits, we always want to find where they're exactly equal to each other, and that's going to be the optimum. So when we're studying a graph like this and we're finding our optimum point where they're equal to each other, we can see that the best amount of pizza for society to make is 2. And if we flip back to the other graph, here you can see at 2 pizzas, then we're at point C, where we're making 2 pizzas and 7 robots. So it tells us the most optimal point for society to be is to choose to produce at point C. The next thing we're going to see is what economic growth looks like on the production possibility curve. If you compare this chart to the last chart that we looked at, if you've got your PowerPoint slides in front of you, you can see that all of the numbers here are larger than they were in the last graph. So economic growth is when an economy can actually produce more than they were producing before. So this economy now can produce more pizza and more robots. So let's see what it looks like on the graph. If we graphed all of these new points from the chart we were just looking at, we would get all of these points out here. So this lower line right here, this was our original production possibility curve. Now we have economic growth, and all of the points have shifted outward. Now, all of these points in here before were unattainable, and now they're attainable because we have economic growth in our society. If we have an increase in the quantity of our resources, so a good example of this is immigration. When we have immigration, we have a larger workforce, then we'll see increases in economic growth in an economy. The second one is quality of resources. An example of this is education. So if we educate our workers, then our workers are higher quality. They're able to produce more, and that can cause economic growth. And the last one is technological advance. Again, remember, this is technological knowledge. So this means we've learned new information or new ways to produce that we didn't know before. So a good example of this is research and development. So a lot of companies do new research to come up with new methods of production or potentially new products. This slide is making the point that it's important for society to decide where they want to produce on their production possibility curve. They can choose to make goods for the present, like pizza, or goods for the future, like education, or capital, or research and development. If a country chooses to produce at a point like this one, where they're making a lot more goods for the present than goods for the future, they will have economic growth, but it will be small. This is an example of a different economy, and they're choosing to produce a lot of goods for the future and not as many goods for the present. And notice they have a significantly higher economic growth over time. So this is one of the decisions where economics overlaps the government's decision or politics. Do we want to make more goods for the present or more goods for the future? Because it's going to make a difference for our economic growth. The last thing to know about the production possibility curve is how international trade can affect the production possibility curve. We will actually look at this in depth when we get to chapter 26. So the first thing to know about international trade is what we're going to do as a society. We're going to choose to produce the goods with the lower opportunity cost, and then we will trade with other nations. When we do that, we're actually able to get to a point outside our production possibility curve, which is normally unattainable. It's unattainable if we don't trade, but if we do trade, we can get to that point. Another thing I want to mention here, because it pops up in the homework that you're going to do, is that it is possible for trading internationally to actually shift the production possibility curve outward, but that's not normally the way that we study it. But it would be possible if, for instance, we're importing resources. Then we have more resources in our economy. That would cause us to have growth, and the whole line would shift outward. So that's a possibility as well. Here is one last activity for you to try. So what you're going to do here is you're going to take all the 6 points, you're going to graph the production possibility curve, put wheat on the horizontal axis, and then you have a few questions to answer. Can the economy produce 3 steel and 40 wheat? Plot an efficient and inefficient point. Plot an attainable and unattainable point. And then you're going to solve for the opportunity cost of some of your steel. So the second unit, third unit, and fourth unit of steel. And then see what happens to the opportunity costs. From E to G, see what happens the more steel is produced. What happens to opportunity costs? So pause the video and try this. Okay. So your graph should look something like this. Excuse the quality of my graph. It's very hard to draw accurately on a computer like this. But it'll make you feel better if yours is as messy as mine is. It's fine. The main thing to notice is that you've got each of your 6 points plotted. And then you just sketch a line through the 6 points, and you should have at least a little bit of a curve here. So hopefully you tried to make it into a curve, and it's not a straight line. It's the production possibility curve. So it looks something like this. Now, next question here, can this economy produce 3 steel and 40 wheat? You can plot this point, 3 steel and 40 wheat. In my graph would be somewhere around here. Looks like it's under the line, so the answer would be yes, that's an attainable point. If you've got a messy graph like me, it may be better to take a look at the chart and see what the economy is doing. So for instance, at point D, they're making 3 steel and 55 wheat, and that's possible if they're at full employment. So they can definitely make 3 steel and 40 wheat, because then they're actually just producing less. So yes, the economy can produce 3 steel and 40 wheat. Next, you want to plot an efficient point and an inefficient point. So an efficient point would be somewhere on the line, anywhere on the line. Do this. That's an efficient point right there. Then you want to plot an inefficient point. So remember, inefficient means there's some unemployment happening. So not all of my resources are being used. Inefficient point would be somewhere underneath the line. Next, we're going to plot an attainable point. So an attainable point means it's possible. They have enough resources to make that amount of steel or wheat. An attainable point can be underneath. It can also be on the line. That's also possible. But I'll put mine underneath. So there's an attainable point. And an unattainable point. Unattainable point is when the economy does not have enough resources to produce that much steel or wheat. And that will happen somewhere outside the line. So this point will be the unattainable point. Now to solve for opportunity cost. Solve for the opportunity cost of the second unit of steel. We can come up here to the second unit of steel. We want to get this steel. That means we're coming from over here. So we have one steel. We want to get a second steel. We want to see how much we gave up. So just come down here to wheat and see how much you lost out of when you got the second unit of steel. So to calculate this, you can actually just do 90 minus 75, and that tells you that you lost out on 15 wheat specifically. We can do the same thing to find the opportunity cost of the third unit of steel. So if we want this unit of steel, it means we're coming from point C and moving to D to get our third unit of steel. When we do that, we move from having 75 wheat to 55 wheat. So we've given up 20 wheat in this case. And for the fourth unit of steel, we're moving from D to E, where we move from 55 wheat to 30 wheat. So again, subtract 55 minus 30, and this time we've lost out on 25 wheat. So what's happening as we move and from point to make more steel? So we're getting our second unit, our third unit, and our fourth unit of steel. The opportunity cost is increasing. Okay. You may also want to jot down here, that's the law that we talked about, the law of increasing opportunity cost. The more steel that we produce, the higher the opportunity cost will be.